I wanted an e-bike for a long time, but I am not willing to pay 700 USD for it. That's almost half the price of my car. So I decided to build one myself in the cheapest way possible. To keep it low cost, I planned to power it with the 20-volt batteries from my parkside tools. My goal was to build something that can go at least 10 km and cost less than 100 USD. First, I needed an electric motor. I made the best deal of my life. For just 13 USD, I bought 5 lawn mowers and some bicycle wheels. And yes, 5 lawn mowers actually fit in my car. I didn't even have to go back for a second trip. What I was looking for was a working BLDC motor and a controller for my e-bike project. By the way, the $13 also include 2 bike wheels along with the 5 battery-powered lawn mowers. Out of the 5 lawn mowers, 3 had brushless motors, but sadly none of them worked. But 2 of the mowers had really good quality brushed motors. So I changed my plan. I gave up on efficiency and went with the brushed motor instead. I couldn't find any technical data from these motors, so I had to measure a few things myself, especially to calculate the correct gear ratio. First, I wanted to know the non-load RPM. I used an Arduino Uno and photosensor to measure the shaft speed. I tested it with a 12-volt battery and it ran at about 1800 RPM with no load. That seemed a bit low, so I tested it again with a 20-volt parkside battery. With the higher voltage, the RPM increased right away. The non-load RPM with a 20-volt battery was now 3000. According to ChatGPT, 600 watts could give me a top speed around 36 km per hour. That's 10 meters per second, so I made that my target speed. If the wheel has a 2-meter circumference, that means I need 5 rotations per second, or 300 RPM. That means I need a gear ratio of 8.5 to 1. The ratio I used in the video was 7.3 to 1. It worked great on flat roads, but hills and starting from a stop were a bit hard. The top speed was around 40 km per hour. Now I use a new gear ratio 11.5 to 1. The top speed dropped to 25 km per hour, but the torque increased a lot, almost infinite. And the range also improved by around 30%. Now I don't even have to have the motor when starting. It has enough torque to move the bike from full stop with no problem. ChatGPT says that a timing belt is much more efficient than a chain drive. So I made mine for a Renault Master timing belt. I also built a gearbox for the motor using this old aluminum gear housing. The gear ratio is 1 to 4. I had to make a bearing holder on both sides of the gearbox. Opa! The motor shaft is 15mm thick, so the best choice was 6202 bearing. I already had one at home and I bought another for 300 forints. That's almost $1. I clamped the gearbox in the lathe using the original motor mount. That way I stayed perfectly aligned with the shaft. By the way, if you are into latte content, check out my channel. I've got a few videos on that too. I also thought about using washing machine belt drive, but weight belts are not very efficient. A timing belt and gear combo is much better. Now I can say from experience. A combo of timing belts and gear works very well. The energy use is around 20 Wh per kilometer, about the same as factory built e-bike. As I mentioned earlier, I had to change the gear ratio using a smaller pulley. At first, I wanted to use a bike sprocket. I always save junk like that for future YouTube projects. You never know when it might help. But even with 1000 bike sprockets, I couldn't get the right gear ratio. And I didn't want to buy anything new because the 13 USD already burned throughout most of my project budget.
Hú, bazd meg!
At first, I wanted to use a PWM module from an old parkside drill to power the bike. But the lawnmower motor didn't really perform well at 20 volt. So I used two batteries in series to get 40 volts. Luckily, I had an old PWM module from AliExpress in my junk box. The PWM speed can be controlled with a simple potmeter. Later, I ordered a proper ebike throttle from brushed motor with a matching PWM controller. It worked by better than the cheapest AliExpress one. Building the battery holder was maybe the hardest part. I originally wanted to 3D print it, but 3D modeling software tested my nerves and my patience. To protect my mental health and my computer, I dedicated not to make a 3D model. Instead, I built the battery holder from steel sheet, some plastic piece, and a 5 empty bullet shells. I thinking I finished it faster than a 3D printer would have. I've been using the bike for about a month now, and I am really happy with it. So I decided to upgrade the project and bought a throttle from AliExpress.
Oppa.
The budget went a little over. I paid 26 USD for a new throttle and a new PWM module. But it was totally worth it. I also painted the steel mount a beautiful baby blue, because hey, design matters. In the past mount, I've ridden about 150-200 km. No problems at all, it works great. With doubles 4 ampere hours battery, the range is around 8 km. If this video gets 100k views, I'll buy double 12 ampere hour batteries from 160 USD. That would give me a range of over 25 km easy. And now for the usual boring part at the end. Subscribe to the channel, because if I hit 100k sub this year, I'll win a 2004 Opel Astra from one of my friends.